tests for this class. So listen, we're doing 3.10 day 2 today, 3.10 day 3 tomorrow, 11 is Monday and Tuesday, and then we have a test review on Tuesday. It's a one-day test review. It's a one-day test. Technically, Wednesday, March 6th, is also a review day, but I'm proctoring the SAT. The juniors are taking the SAT, so I won't see you guys on next Wednesday anyway. And the test will be Thursday, and Friday will be a makeup day. So there'll be a day in between reviewing and the test, so make sure you look at it the night before and stuff. But we'll talk about that next week. But because of the breakup in the schedule, I wanted to give you guys lots and lots of time to work on the review. So my plan is to have it ready for you guys by tomorrow. That's what I was going to work on. So I'm almost done with it, so I still should be able to have it ready for you guys tomorrow. I just might take an extra day to get the key going, but at least you guys can start working on it. It's 9 multiple choice questions and 1 FRQ. So very manageable for a class period review, class period test, okay? One of the big things I'm having trouble with, and I don't know if any of you know PowerPoint really well, I can't get this triangle off of that problem. I don't know how to get rid of it. So if later on somebody wants to try and help, I'm in PowerPoint, editable, I cannot get that triangle off. So it might just stay. It has nothing to do with the problem. It's just a cut and paste job, and I can't get rid of it. So if somebody wants to help me later, I would be so appreciative. But for now, let's go through today's lesson. Okay, we're just doing this page of notes. Then I'm going to do 4 of the homework problems with you just to kind of solidify the different types of problems you can get. And then you guys can work on it, looking at the key, helping each other while I get ready for the thing that we talked about. Okay, so everybody good? All good? Okay, we're going to be together for a long time today. Get a snack, get comfy, all right? So what we're doing is continuing to solve trig equations. We kind of started them yesterday. We're taking it up a little bit higher of a level today. Not too bad. Really, the worst ones are the ones where you have to remember how to factor. The chart problems, that's back. I told you guys it's going to be part of this class, something we have to know how to do, and you'll see a review of that today. When we get to that, I'll talk about it. All of the problems today are on the unit circle. We do not have to worry about the 2 pi k or the pi k. We only use that when it says what in the directions. All.
Good morning once again, Countryside High School teachers. We apologize for this interruption and want to clarify that our youth mental health lesson, our bell schedule is for this period 3rd. And so please make sure you are engaging in that curriculum at some point during the block scheduled time. We appreciate everyone's activity. And thank you for your attention to the schedule.
Guys, don't be nervous for me. It's just something extra I have to do where I would normally want to walk around and help you. That's all. So I'm just giving you my position. It's going to be fine. Don't really worry about it. Okay. Okay. All right. So let's solve. So when you look at a problem like this, what I want you guys to notice is that there's an x squared in there. This problem is in the form of an algebraic equation that would look like that. Okay, the only thing that's different is they put the word sign in there, and they do put the squared, notice, on the word and not on the variable. That's just a trig thing. It still means sine squared x. The whole thing is squared, okay? But if you were confused by this, you could always take the sign out and, of course, put the squared on the x and say, how would I solve it if it looked like this? This problem is in the form of a quadratic where we're missing the b term, okay? We don't have the bx. Whenever that happens, we use this by finding the square root. We get everybody on the other side together, okay? So I'm going to skip some steps today because I think we can handle it. Add 1, and then what? Divide by 4, okay? If you need to show more steps, feel free to do that. If you don't understand how I got to a step like that, ask me, all right? And so same idea, you would have x squared equals 1 over 4. We need to get rid of the squared. Remember, our goal is to get x by itself. So we have sine here, and we have that squared. So just like in algebra, what I would do next is take the square root of both sides, okay? Which gets me sine x by itself here. So square rooting a square gets rid of the square. And then we would take the plus or minus, right? Anytime we do the square root. And in this problem, both the numerator and the denominator are perfect squares, so we get 1/2. Now remember, we're solving for x. X is an angle, okay? X is an angle. So what they're asking is where on the unit circle do we have sign that's positive 1/2 and negative 1/2? Again, for the same reasons I've been saying for the last few days, if it helps you to have that reference angle written down, go ahead. If it doesn't help you, don't do it. Your brain, your work. So when I quickly look at that, I go, oh, it's all my denominators of 6 because sine is 1/2. And I don't even need this because I want all the positives and all the negatives. So these square root problems are kind of nice because you just take all of the same denominators, all 4 denominators of 6, the 2 positive and the 2 negative. So I just go right around the unit circle. Quadrant 1 is just pi. Quadrant 2, I subtract 1. Quadrant 3, I add 1 to my denominator. And at 5, 7, 11. Pretty easy. Same thing. Let's just do tangent this time. Add 1, divide by 3. Got to get rid of the squared, so we would square root both sides, which leaves us on the left-hand side with tan x, and on the right-hand side, plus or minus, the square root of 1 is 1, and the square root of 3 is going to give me a decimal. Okay? So I have to fix this. Now, if you want to show the work, it's fine. If you kind of start memorizing this, you might even have it memorized from yesterday. When you have a radical in our denominator, we will rationalize it, meaning multiply it by itself, and that gets you, sorry, yes, that was right, square root of 3 over what? 3. So this equals plus or minus square root of 3 over 3. So anytime you end up with this 1 over the square root of 3, you can just say, oh, I know what that is for that reason. Okay? What's our denominator going to be? 6, right? We know those tan rules. You guys said that a lot faster this time. So tan square root of 3 over 3. And we want the plus and the minus. So it's the same answer we just wrote. It's a very popular one today, you'll see. We use our denominator of 6 a lot. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay? So how we would get rid of a radical, get rid of a squared term would be that. Well, look at example 6, A and B. We're just going to do A. I'm going to need that whole space to do it. So I'm going to show a lot of work here just this first time to make sure we remember how to factor. This one is in this form, ax squared plus bx plus c. It's got the b and the x in there. It's got the quadratic, but it also has the bx. So if I just add 1 and divide by 2, I'm still going to be stuck with a squared variable and just the variable. So I can't use that method. This type would be the factoring type. So what I want you guys to notice is really it's this equation. And if it helps you to write it just like this and work with it as a quadratic trinomial versus a trigonometric trinomial, that's totally fine. That's typically what I do. I'll deal with it. I just took the word sine out, okay, and squared the variable in that first term. And then this is familiar to me. This is a chart problem. I'm asking myself what two numbers multiply to get -2, add to get -1. If you have trouble factoring, I'm not teaching it here, okay? If you go into modules and go to the very bottom, the last, because all of your modules are still in there. From every single test we've had, everything is still there. I just always put the most current one on top, okay? But if you go to the very bottom, I think the bottom one says midterm exam review, but the one right above it says Algebra 2, keys, all the pink sheets. That's where the factoring video and factoring notes are. So if you need to refresh your memory, that's where you go, okay? So -2 times 1, -2 plus 1. And because of the 2, we have to bring down the outside 2 terms and split the middle into these two numbers, putting a variable on them. It doesn't matter which one you put first, but if one of them's negative, that's usually the better choice for the first term, is putting the negative first. And then we do our parentheses and GCF. Even if all you can pull out is a 1, you have to pull that out, okay? So even if you have to factor out a 1, something has to go in that spot. Then, you know, the heart part of the problem. Hi.
I'm sorry to interrupt.
No, it's fine.
Do you need any support on that other topic we were talking about?
No, I have wonderful students, and I shared with them that I'm going to need a little bit of time to.
Yeah, the video is 25 minutes.
Okay.
And then during that, it's just 4 questions that we're going to take it out the door. I can remove it. Do you have to take it out?
I don't.
I'll bring you there.
Okay. Thank you so much. Thank you, Mr. Henderson. It's okay. All right. So 2x plus 1 and x minus 1. Okay. So here's where I'm going to pivot. That's the word of the day, I guess. Pivot back and put sign back in. Because we're not really just doing this. We're doing a trig problem. So, and again, I'm showing a lot of work. You could have kind of skipped some of these steps maybe. But right here is where I put sign back in. And where do I put it? Just in front of the variables. Right in front of your x's. So we were working with sign, so that's where I put sign back in. Now, this looks like the problems you had yesterday. Number 7 and number 8 in your homework, they started at this step. They gave you 2 parentheses set equal to 0, and my directions were take each of them and set them equal to 0 separately and solve them. Okay, so when I set this one equal to 0, here I am skipping some steps, you would subtract 1, divide by 2, right? Subtract that 1, divide by 2. You can skip steps, guys. You don't have to show everything. If you need to or just like to, of course you can, but I'm giving you permission to not show every step. Okay? And now we answer the question. So, again, this is our denominator of 6, right? But where is sign negative? Sign is negative in 3 and 4. In quadrant 3, I add 1. In quadrant 4, at 5, I go to 7, 11. Okay? In this one, as I say always, I don't trust myself with sine or cosine with 1s and 0s, or even tangent with 1s and 0s. You guys, I cannot tell you how many times I draw myself this diagram. And I'm good at trig. I am good at trig. I love it. But I still need this little picture. I need it. So, and I keep sharing that with you, making a big deal out of it, because I want you guys to feel comfortable having to show work at times. Okay? So where is sine, like, there's no shame in having to draw this picture. That's what I'm getting at. Where is sine positive 1? Where? Up at the top. What is that? What's that? That angle is pi over 2. Remember, we're always in radians. There's only one of them. There's only one place that sine is 1. Good? So treat a trig quadratic as a regular quadratic and then sneak the sine or the cosine or the tan back in and then solve it like we do the others. Okay? So I would say most people find this the hardest part of today's lesson because they forget. All right, last one. We're only doing this last one and then we'll go to the homework. Take a look at this problem. This is another way of saying from 0 to pi, 2 pi, right? That's just same as 0 to 2 pi. What I want you guys to notice about this problem, and it's really important, because you solve these problems the same way every time, from the top of my head I can think of, at least today. When you are mixing sine and tan in one problem, or sine and cosine, or if you're mixing different trig functions in the same problem, there's going to be one method you use. So let me relate this to algebra, okay? Let me call sine x and tan y. So what you could relate this to in your own, like, past would be x squared y equals 2y. So we have x's and y's mixed together in the same problem. So what you would do in this case, you don't have to write this, is you would get everybody on one side together. So I subtracted 2y. You want to always have a 0 on the other side. And then I would factor out the GCF, which would be y. And once we get to this step, these are both factors, just like these are both factors, meaning multiplied. You could set them equal to 0 separately, which is what we did here. Same thing here. I could do y equals 0 and x squared minus 2 equals 0. We're going to do the same idea with this problem. You start by getting all of the terms on one side together. So I would subtract 2 tan x from both sides to get a 0 on the other side. What would the GCF be? Tan, right? Look, we have a binomial, one term minus one term. So they have tan in common. So that's what I would factor out. That would be my GCF. And you don't need to write this, but essentially what you're doing is the reverse of the distributive property. You're dividing both terms by that word, number, letter, whatever on the outside. Whatever's left over goes on the inside. Now that they are factors, you set them equal to 0 separately. So I have tan x equals 0. That's this guy. Set that one equal to 0. Save yourself a step. And go ahead and move the 2 over, right? Minus 2 equals 0, but I added 2. And then you would have to do the square root of both sides. So here's what happens sometimes. Sometimes we have numbers we recognize. I'm going to use my picture up here. Remember, guys, tan is sine over cosine, or y over x. Either way you want to look at it. So whenever I have to do tan and with my quadrantals, I'm looking for y over x, y over x. So that's 0 over 1 or negative 1. That's here and here. Because 0 divided by any number equals 0. So for this part of our equation, x equals 0 and pi. Okay, so those are two solutions. Here, if you put this in your calculator, it gives you an error message. This is not a number we know. It's not like square root of 2 over 2, which would be our denominators of 4. It's just the square root of 2. When you put that in your calculator, you will get an error message. So that happens sometimes. We get extraneous solutions from that. Okay? Anytime sine or cosine equals a number greater than 1, you're going to get an error because their range is 1 to negative 1. And this is 1.4 something. But you can just put it in your calculator. In radian mode, it will give you the wrong answer. Okay? So we're going to go to the homework. And I'm going to do 1, 2, 4, 5. 1, 2, 4, 5. So give me a second to write a few down. I'll write one down in here. All right, C27. All right, so this is like the one we just did, right? Sine and cosine mixed together. Everybody's already on one side together, so we don't have to do that step. We just have to figure out what the GCF is. What would the GCF be? Cosine x, right? So I have a couple of students last period confused about what is cosine x divided by cosine x? It's just 1, right, Sabine? Cosine x divided by cosine x is just 1. Just like 4 over 4 equals 1. The square root of 2 over 2 divided by the square root of 2 over 2, 1. X over x, 1. Okay, so when you divide something on top and bottom that are the same, they cancel out, you're left with whatever's there. In this case, it's just 1. And then cosines would cancel there. Now that they are factors, meaning multiplied, you set them equal to 0 separately. subtract 1, divide by -2, that might be one that you have to show work for. Maybe not. Subtract 1, divide by -2, you get positive 1/2. Okay, cosine is 0, top and bottom, right? Top and bottom. Top and bottom. So that would be pi over 2 and 3 pi over 2. Send me another. Send me another. I dare ya. All about this thing. Okay, so if you need to write your reference angle, there it is again, right? Sine is 1/2. Sine is positive in quadrants 1 and 2. All students. And then you have to write it that and subtract. Okay, so we ended up with 4 solutions in that problem. Okay. Number 2. Oh, this is interesting. Go ahead and, while I talk to you, go ahead and get everybody on one side together. So you're going to subtract tan squared x. If you look at the directions for this set of homework, it says your solutions will be from 0 to 2 pi, and it's written like that. That's different. That's different. Normally, it's a parentheses there. I've actually never seen that, and I don't think it's a typo because she actually included 2 pi's in some of her answers, but normally we don't. It's usually parentheses there because 0 and 2 pi share the same spot. They're coterminal, so we normally don't include 2 pi. The only reason I can think of that she did this is because she knows something we don't, that could be thrown in on a question, so we have to pay attention to it. So we're paying attention to it, and you'll see why it matters on this problem. Okay, hopefully you guys agree with me that tan squared x is our GCF here. And I know I'm doing that GCF thing because we've got mixing up of 2 different types of trig functions. Setting them equal to 0, and then of course this one I added 1 to the other side. Okay? Square root, square root. The square root of 0 is 0, but we don't have a plus or minus 0, right? 0 is neither positive or negative. And over, it's, yeah. And using my picture again, remember, sine is y over x. So we're at the top and the bottom again, pi over 2, and 3. Nope. Sorry, we're not at the top and the bottom. We are here. Who caught me? You doing it? Somebody caught me there. Tan is 0 over 1. 0 over 1. So when we get tan is 0, it's going to be at those 2. But look, this is what I was talking about. It's going to be at 0, at pi, and where else? 2 pi. So weird. Because these are coterminal. It's kind of weird to include those. But because of that one little symbol. Okay, and cosine being 1, where does that happen? 0, and yeah, see, normally we would not include 2 pi. It just feels weird to me. But again, we're just going to stick with what we're told to include 2 pi as well. So let's just say that's something we're going to pay attention to, so we make sure. But most of the time it's like what the direction, like our homework was, which is, I mean, our notes, remember it was like a parentheses there, so we never included 2 pi. Weird. All right, I'm going to skip to number 4 because we didn't have one in our notes exactly like that. I think we did yesterday, but. So do this one with me, and I am going to do number 5, which is a factoring problem, but if you are good at factoring, you can go back and do number 3 because you hate being out of order or whatever. Okay? So, guys, notice this is not a mixture. It's only cosine in there. Okay, so there's only one, so it's not a GCF problem. There's nothing that's squared, but what you should notice is you have 2 like terms. Okay, this is 1 cosine x and this is 5 cosine x. Let's get them together on one side. And I said x, theta, whatever, same thing. So this is like a 1, don't forget. And then what? Divide by 4. So I'd have cosine theta equals 3/4. I don't know that number. That's not like 1/2 square root of 3 over 2. It's not one of the ones I recognize. That tells me go to my calculator. And so I need quadrants 1 and 4. So this is where you have to remember the differences in your quadrants. Because remember, your calculator will only give you quadrant 1, which we need, thank you very much. But how do we find 4? So quadrant 4 is the whole thing minus what you got in your calculator. How do you remember whether you're going to add or subtract? Let's just talk about that real quick, because that's usually what people get confused about. How do I remember when I'm not subtract or multiply? So guys, this is pi right here. So for quadrant 2, I want to be less than pi. So I would subtract whatever I got. And in quadrant 3, you are more than pi, right? 5 pi over 4 is more than pi. So we would add to pi to be bigger than pi. And again, quadrant 4, we want to be less than 2 pi. So it makes sense that we subtract from 2 pi. Okay? So quadrant 1 and quadrant 4 is what we need. Okay? And you don't have to write that, but I'm just kind of reminding you. So putting it in my calculator, wherever C is, you would always want to make sure you're in radians. Second, oh, that's the other thing. We are trying to find an angle, right? Anytime you're trying to find an angle, you have to use your inverse button. Even though it doesn't say it, that's up to you to know. We're trying to find x or theta, that is an angle. So anytime we're trying to find an angle, use the inverse button. So second cosine 3 divided by 4, and I get 0.723. And then I'm going to do 2 pi. I'm going to get my old calculator back. This one is driving me crazy. 2 pi. Oops. Can't see it either. These buttons are smaller. 2 pi minus our answer. So I'm going to use second answer. And I get 5.560. And you could put the 0 on. Okay? So sometimes you have to pick up the calculator and try it. Sometimes you just know it from the unit circle. All right, last one I'll do with you. I'm going to do a factoring one. So if you have trouble factoring, you should be paying attention again. And then going on Canvas if you need to. Watch the video on factoring. Okay, so 2 cosine squared. I'm going to change it to x just as I started writing an x. Remember, it doesn't matter. Theta, x, y, z, alpha, gamma, zeta, beta, whatever letter you want to use. Okay? So this is a quadratic trinomial. We have an x squared, an x, and a constant. So I'm going to say, I'm more comfortable seeing it like this. But you don't have to. You can totally write cosine a bunch of times in here, but I think it gets a little confusing. I'm going to ask myself what 2 numbers multiply to get -8, add to get -7, and it would be those numbers. Remember, when there's a 2 here, we have to do that extra, bring down the x outside 2. If it was an x squared, it would just be these 2 numbers. So I brought down the outside 2 and split the middle into these 2 numbers, putting an x on them. GCF. No, it's just 500 emails about this mental health lesson. Swear to God. Okay. So 2x plus 1 and x minus 4. But we're not in quadratic land. We are in trig land. So I'm going to go ahead and put sine in each of these and kind of combine a step here. Oh, I did this last period too. It's cosine, thank you. It's cosine. Sorry about that. Okay, so 2 cosine x plus 1 set equal to 0, and cosine x minus 4 set equal to 0. And then subtract 1, divide by 2. That's negative 1/2 here. By the way, this is greater than 1. Anytime this number is greater than 1, you're going to get an error message, but you could put it in your calculator and find that. No solution over there. This is my denominators of what? Did someone say 5? I thought I heard 5. Okay. And remember where cosine is negative, 2 and 3. So quadrant 2 subtract 1, quadrant 3 add 1. And those would be your only 2 solutions. Okay. So I'm going to put the key up. And I don't know how long it'll take me to click on it. They made a big deal out of this one because it is the suicide one, and it's a very sensitive subject. And so if they have offered a way for you guys to opt out of this if you didn't feel comfortable. They did it through something, calling home, whatever, but a lot of parents maybe didn't see it. So if anybody is not wanting to, I have a place to send you. So if you are someone that doesn't want to do it, talk to me before I start, and I will tell you what I can do for you. Okay. You have to go to the auditorium, and they take attendance there, so it's not like a free period. Don't think that. But Miss Alexander will be there. We will be sending a list to her of anyone that opted out. She will be checking attendance there and all that stuff. So it's a process, but it's totally fine. Happy to make it happen for you. This is not something you want to be part of. I think I was able to fit the whole 2 there. So remember, you have to go back and do 3 and 6 only in the first page. So you actually have the benefit, guys, even though you were sighing about having to do your mental health lesson in here. We're not even supposed to start for another 6 minutes. So you have a little extra time to work. It's just a shortened period, so everyone else kind of got cut off quickly. So if you just give me a minute or 2, so I can review this.
Hello and welcome.
Oh, not ready for you. Hush, hush now. Sadie, you looked a little interested in my PowerPoint problem. You think you would know how to fix that? Okay. If you wouldn't mind, I got it right here. See, it's just typical of you to say that. See, she just wants to help me out of the goodness. No, I really tried. It's like you can fix it. Got it.
I clicked on the triangle and hit delete.
No. Okay, wait.
What'd you do?
Okay, I couldn't get that box around it. I couldn't find. So how did you see how I'm clicking on? I can't. How did you box it like that?
I just kind of clicked around it until it decided to work.
Oh,
Now
is
it's
that
not
right?
decided to work.
Yeah.
Go back. Stop that. I think it's very cool.
Oh, so you, it's kind of sensitive, right?
Because it's in another picture.
So you. Anyway, did you drag it out of there for a reason?
I was making sure that I had the right one.
Oh shoot. Oh, I had it. Wait, am I on it?
Yeah.
Can I just hit delete?
Yeah. I think you're on the
So annoying. Not you.
Oh,
Thank you. Now I don't have to print it with a triangle right in the middle of the problem. How are we doing with this lesson, guys? Do you remember, Tyler, what I chose? Did I choose microphone in, line in, headphones, or headset? Line in sounds better. That's not, because what device did you plug in? I would think this is a line, right? This thing.
Yeah, probably that.
I'm going to try that. Wait, external speakers?
Or that probably
And
works.
it's highlighted too. I'm going to tell it not to show it again so I don't ask this question every time. Okay. Oh,
There we go.
you guys are teaching the teacher today. I appreciate you.
You are.
I am. I'm constantly learning.